everybody, Mr. Johnson back with you, and in this video we're going to be looking at something called a Galileo Ramp. The reason it's called a Galileo Ramp is that when you go back and look historically, Galileo Galilei did a lot of experiments rolling metal spheres down inclined planes. So in his honor, this type of ramp is called a Galileo Ramp. As far as the construction, what we've got is just a metal track, but the key point is that the starting point and the ending point are at the same height. Okay? The other thing is we start out with a nice gentle slope and then end with a steep slope. So let's do the demonstration. So first thing I'm going to start with is a metal sphere, nice smooth metal sphere. And the question becomes, when I roll this metal sphere down the track, one, will it reach the end? But two, if it reaches the end, will it possibly go over the end? So let's try that out. I'm going to start it out. It rolls and almost makes it back to the same height that it started with. What about if we start at the other end? The steep slope and then into the shallow. So again, started at the end. Almost makes it to the end. Okay? So that's this sphere. Next, I'm going to do a golf ball. So place the golf ball on here and do the same thing. Doesn't quite make it. What about from the other end? Same thing. So let's delve into this and what's going on. Why, first off, does the metal sphere go further than the golf ball? Okay. Well, that comes down to frictional forces. Nice smooth metal sphere, rough surface golf ball. And one of the things that we can use this Galileo track to first start talking about is the idea of frictional forces. Okay. When you look at frictional forces, there's this thing called the coefficient of friction. And what we find is the smoother the object, the lower that coefficient of friction. Coefficient of friction is just a percent. It's a decimal, and what it tells us is what percent of an object's force normal is going to end up resulting in frictional forces. So the larger the coefficient of friction, the more energy lost to frictional forces. So the smoother the object, lower that coefficient. Rougher the object, larger the coefficient. So as a result, golf ball is going to have greater frictional forces. And this is what Galileo would have seen as he's rolling these spheres down these inclined planes. He even said that there is a resistive force to motion. It's what we now know as friction, and it's what Isaac Newton took and expanded upon. Okay? The other concept that we can use this for is the idea of conservation of energy. Okay? I start out with potential energy, gravitational in fact, and then as it rolls, that potential energy becomes kinetic, and then as it starts to move back up, that kinetic goes back into being potential energy. But I lose some energy again due to frictional forces, and we can actually hear that loss of energy. Take a listen. That sound, that's energy that's being lost. Okay? So we can talk about conservation of energy, that this is not a perfect system where 100% of the potential becomes 100% kinetic. I lose some energy out of the system as, say, mechanical energy. Okay? Same thing with the golf ball. Hear that sound. It's a loss of energy. Okay? So this is, again, Galileo Ramp, and we use this again to talk about conservation of energy. We can use it to talk about inertia. An object in motion tends to stay in motion. An object at rest tends to stay at rest. We can use it to talk about frictional forces and a lot of other things. So I hope you've enjoyed the demo. If you have any questions, just leave them in the comments. I'd love to hear from you. And as always, thanks and take care.